Okay, what we're going to do is explain how the kit for the bar graph voltmeter works. Here's the circuit, and I'm just going to walk through it now and then just give you an example of it working. So what we've got here on the left hand side is basically a voltage divider, and each one of these sections on the division of these resistors is attached to the non-inverting input of these comparators. Now these are op amps, 471 op amps, but in the kit I've combined all of these into a single 14-pin IC, which is a lot easier to handle. So, and it's also, there's less space involved. But for this demonstration, I've done it on a breadboard. So when you'll see that in a minute, it's in a breadboard, and there's actually 4 op amps, just so you can see them all. So let's just run through it. So for example, this voltage divider 9 volts. What we've got here is a potentiometer here. Now we adjust this so that we see exactly 2 volts. We can use a voltmeter to do this, it's really easy. So we adjust this potentiometer, and this is a 100k potentiometer. So we can adjust this to have more of the voltage drop across this than across all of these. Now these are all the same value, all 1k. So whatever we drop across this 100k, whatever we set this resistor to between 0 and 100k will determine the voltage that drops across all of these. So what we do is we set that until we can find 2 volts across here, and that will put 2 volts across all of these because they're all the same value. So you'll have 2, and then this one will be 4 from the ground, and this one will be 6 from the ground, and this one will be 8 from the ground. So that sets up our voltage divider. So those are our reference values. Now if we place a value on the voltage in, let's say we place 3 volts on the voltage in. Now if we place 3 volts on the voltage in, then 3 volts on the inverting input is actually higher than 2 volts on the non-inverting input from this voltage divider. So because this voltage is higher than this voltage, then the non-inverting is going to force the output to go low. Now when the output goes low, we've got 9 volts on this side, so charge then can flow, because charge will flow from a high voltage to a low voltage. So charge will flow through here, and it'll flow through the LED and activate the LED. So one LED will light up. So let's say this time we step it up. We actually put on the voltage in 4 volts this time. Now 4 volts, what's that going to do? 4 volts on the inverting input is higher than the 2 volts here. So again, this LED is going to light up. But now here, 4 volts on here is not higher than the 4 volts, so we still only got LED 1 lit up. So it's only the one LED will be lit up. So that means to make 2 light up, we need to get above the 4 volts. So if we place 5 volts on the voltage input, then we've got 5 higher than 2 volts, that's going to go low. And then here, 5 is higher than 4. That's going to go low, so then you're going to have 2, and you can see that's going to happen again. If we tried 5 volts, then you still only have the 2. If we had 5.5 volts, you still only have the 2, but as soon as we get above 6 volts, then all 3 will light up. So you can see that this is a very rough voltmeter. It only gives you an accuracy of 2 volts, so you've got an error of 2 volts between each transition here. If you wanted something finer, then what you could do is build a circuit with several of these op amps. So if you had 8, for example, then you could easily have a 1 volt accuracy. You know, if you had 16, you could have half a volt. So you can see, you know, this gives a good example of how you can get a nice display here on these voltages. So for example, it can be quite useful, even this simple circuit. So if you're checking 3 volt logic and you're checking 5 volts on the inputs of, say, MP3 players, etc., you can check the 5 volts, because obviously 5 volts will get you LED 1 and LED 2 lit up. LED 3 won't be lit up because that's 6 volts. So it's good for checking 5 volt devices. So that's it really. There's very few parts. It's just, like I say, 4 comparators, or op amps in this case. They'll be on a single chip, of course. And then you've just got 1, 2, 3, 4, 5, 6, 7, 8, 9 resistors. Now these resistors here are just to protect the LED. If you didn't have a resistor there, you'd have 9 volts across that. It would just, the LED would just pop in an instant. You can try that if you want. But 9 volts across these 1K reduce the current quite significantly so that the charge flowing through the LED won't destroy it. So that's what these resistors here are for, and that's the whole circuit. It's a really simple circuit, but it's quite good because it uses the op amp. It shows you how op amp works in the comparator mode, and the fact that nothing is loaded on this side. The nice thing about op amp is no current flows in or out of these inputs. So this side is completely isolated from this side, so it's quite nice. Nice little circuit, nice example of comparators. So that's that. What I'll do now is I'll just show you it working so we can show you how you set those up. So this is it on the breadboard. Now what I'll do is I'll set this up with the voltmeter so you can see what's happening with the voltmeter. Okay, I've got a setup here. So what we've got is a voltmeter dropped across one of these resistors to give us this resolution. You see it's showing 2.04 at the moment, and this voltmeter is just going to be used just to find out what the voltage are on these test cells that we're going to test to see how the LEDs respond to these. So just want to show you how you can adjust the resolution on this. So here I've got 2.04, but with this 100k potentiometer we can change that, so hopefully you'll be able to see the change on that. And look, I've just changed it down to, now that's 0.79 of a volt, so now there would be that resolution. But you know, so if you have 0.79 and you multiplied that by 0.79 times 4, then you've got, you know, from the bottom here to the last resistor you'd have 3.16 volts. So that would be not very good really. So that's the reason I've chosen 2 volts, just so you could have a slightly bigger voltage. So you could get up to 5 volts basically for your MP3 players. So you are kind of limited because we're only using four comparators. If we had 8 comparators, then you would be able to have a resolution of 1 volt. Wouldn't be a problem. Set that back to 2 volts then, and then we'll check how good this is for checking those test cells. So let's just change that back. So now what I'm going to do is get that onto 2. Alright, that's pretty close. That's 2.01. So what we should find is that if I now measure these cells, and then we should be able to predict how many of those lamps light up by remembering it's in 2 volt. Each of those is in 2 volt jumps. So I'm going to use this now, this meter here, to measure these test cells. So the first one we're going to measure is this smaller 2 cell. So let's just see what that says. Well, that says 2.65 volts. So if that says 2.65 volts, well, that means there's a 2 volts on this one, 4 volts here, so only one of those LEDs should light up. So let's just check that. So we'll place that there. So now we're going to measure the voltage with this voltage graph, LED voltage graph. And there you go, there's one LED lit. So we know that that is over 2 volts and it's under 4 volts. This one is around 5 volts, but let's just get the exact value. There you go, it's 5.16 volts. So if we check that, what's that going to give us? Well, 1, 2, 3, 4. Now this third one will be 6 volts, so that means we're only going to get 2 of those LEDs lit up. So let's just see if that's the case. And there it is, 2 of those are lit up, because that is 5.14 and the third bulb would be 6 volts. So we've got that one's working. Let's try this one. Now that's pretty flat, so let's see what that actually is, the voltage on that cell. It's 8.33 volts. So if that's 8.33 volts, then that means all of those bulbs should light up, because 2, 4, 6, it goes to 8. So 8.13 is over 8, so it's just over. So if it's just over 8, we should see all of those bulbs light up. And there they are, they've all lit up. The 2 yellow at the top and the 2 green. So there it works. So you got quite a coarse resolution, only 2 volts between each LED, but it's quite good for things like MP3 players, which often run about 5 volts, 5.5 volts. So quite good for that. There's also quite a number of devices that are 3-volt devices, so you can check it for that. And like I say, if you wanted a finer resolution, you would just build a similar circuit to this, but with more op amps included. You know, you double the amount, and you can get half the resolution again. Yeah, you get a finer resolution. So that's basically how it works, and that's the bar graph voltmeter.